Hello there, Wildcats. Welcome to our Algebra 1. In this video, we'll be discussing about transformations of exponential functions. Our objective is to translate the graph of an exponential functions vertically and horizontally, identifying the effect different values of h and k in your exponential functions have on the graph of the functions. And then we're going to compare characteristics of two exponential functions represented in different ways, such as tables and graph. So we're going to review on the vocabulary, the constant, exponential functions, and translation. And also, I want also to tell you that you have to get ready with your calculators that we downloaded in your laptop. All right. So the essential understanding here is that the values of constant h and k affects the graph of exponential functions. Changing the values of k results in vertical shifts in the function's graph, vertical shifts, okay? And changing the values of h results to the horizontal shift in your function's graph. All right, let's take a look at this first example. How does the value of k affect the graph of f of x is equal to 2 raised to x plus k? So whatever number that you subtract or you add after your 2 raised to x. Let's see. I'm going to, I need my calculator here. Right, so let's take a look at if we put here one of the function g of x is equal to 2 raised to x. Maybe we can add let's see, k is equal to 3. Okay, so I add 3 here, and then another function which is j of x is equal to 2 raised to x plus, minus 3. Okay, minus 3. So what is the difference between these two exponential function? All right, so let's graph this one. You can do table of values. All right, so the table of values, let's say the value of x and then the value of the function. Okay, so I'm going to use this table. So I'll start with -2, -1, 0, 1, and 2. So you can put there g of x and then your f of x as your is equal to 2 raised to x. Okay, and then you also have your g of x. That's because we are going to compare g of x and j of x from the mother function or the original function 2 raised to x. So a lot easier to do that is we're going to use our calculator here. So I just need this one. So I want you to go to y equals. So you go there. Okay. Just take a look at get this one here. Smaller. So y equals, and then I'm going to put my original equation 2 raised to x first. 2 raised to x. Okay, that's my original equation, and take note that the graph here will be blue in color. Okay, and then I'm going to go down. I'll press enter, and then I'll just put 2x, 2 raised to x, sorry, 2 raised to x, and then plus 3. And remember, sorry about that, it's not there. 2x, and then I will go down here, plus 3. And I also have to press enter, and then I'll put 2 raised to x, our mother function, and then I'll go plus minus 3. Remember the colors, guys. So the graph, the blue graph will be our mother function there, and then the red graph will be the plus 3, and then the black graph will be minus 3. Let's see. I'm going to press graph here. So the blue graph, that is your matter function. So from there we can compare. So the red graph will be your x plus 3, and then you have the x minus 3 is the black one. Okay. Okay, so those are the three graph. So we have the blue one, which is our matter function, 2 raised to x, and then we have 2x plus 3, and then 2 raised to x plus 3, and then 2 raised to x minus 3. As we can see on the on 2x, okay, the red color comparing to the blue color, the graph of the blue color here is the vertical translation of, so the red one is the vertical translation of the blue color here. If k is positive, I want you to take this down. If k is positive, the graph is moved up. All right. While your f of x is equal to 2x plus k is a vertical translation of the graph of f of x is equal to 2x. If k is negative, then it moves down. Okay, I'll repeat that. So as you can see, we have the blue, it was translated going to the red one. Then we also have the translation. So the translation goes up here, okay, while the red one, it goes down because k is negative. So that is your vertical shifting or vertical translation. All right, so for our next example, we are going to take a look at the horizontal translation. So I'm going to give you two examples here. So for letter A, we have to compare the graph of g of x is equal to 2 raised to x minus h with the graph of our matter function, which is f of x is equal to 2x. When h is greater than 0, what is the what effect does h have on the graph of g? Well, the second one is we are going to compare the same graph with a matter function 2 raised to x. When h is less than 0, what effect does h have on the graph? So I'll go again and grab my calculator here. So let's start with this one. So what if we are going to compare, sorry about that, g of x is equal to 2 raised to x minus h, and we're going to compare that with the matter function that we have, which is 2 raised to x. And if, let's say, h is equal to must be greater than 0. So let's say 5. Okay, so let's graph that using our calculator. I'll just grab my calculator here, and then first is I'm going to plot this one. Y is my original function 2 raised to x. Okay, 2 raised to x, and then I'll go down with 2 raised to x minus our h is minus 5. So let's graph that and take a look at what happened. Okay, the blue one is the original function, which is your f of x is equal to 2 raised to x. And let's see what happened for the g of x. Take a look at this one. So the g of x was translated horizontally. It moves horizontally. So when we let h is equal to 5 and we compare that with to the graph of f of x, so when h is greater than 0, the graph is translated h unit to the right. So the graph of g, so it was translated 5 units. So the graph of g is a translation of f to the right by 5 units. Okay, so this is our original equation. It was translated 1, 2, 3, 4, 5, and it moves like that. Okay, how about if we do the same on this second here? We do it the same, however, okay, however, we have, let's say, h here, f of x still the same. F of x is equal to 2 raised to x. However, here, because it says there it's h must be less than 0, so I will let g of x is equal to 2 raised to x minus h. And if h is equal to -3, what will happen? So I'll just go over with my graph here. I'll just delete everything. Your 2 raised to x will stay the same because that's what we are, the comparison that goes there. And then I'll just change my it's -5. So we'll just change the value of 5 here, and we'll be using -3. And because it's negative, so this will become a double negative, will give us a positive. I'll just change the positive and then 3. So if h is equal to -3, what will happen to the graph with respect to the original equation or original function, which is 2 raised to x? So let's hit the graph there. So this is our original function, wherein that is our baseline of comparison. And then take a look at h when h is -3. Okay, so when we let h, so we'll be basing it here on the graph. When we let h to be a negative number, which is, in my example, we have -3, the graph, when we compare the graph of j of x, which is equal to 2x plus 3, to the graph of f of x is equal to 2x, when h is less than 0, the graph is translated h unit to the left. It goes to the left. If it is greater than 0, it goes to the right. The graph of j is translation of f to the left by 3 units. So 1, 1, 2, and 3. It's here. So that's the difference between these two here. So the first one, I'll just remove that. The first one, it was translated 5 units to the right. And then the second one, it was translated to the left thrice. Okay, so let's take a look at the summary of this one. So we did the vertical translation and horizontal translation. So in algebraically, f of x is equal to a raised to x plus k. That's a vertical translation. While horizontal translation is f of x is equal to a raised to x minus h. So in horizontal translation, if it is if your h is greater than 0, so it translated to the right. If h is less than 0, it's translated to the left. While for vertical translation, if your k is positive, it goes up, and then if k is negative, and then it goes down. All right. Thank you so much, guys, and we'll see you in our next video. And if you have any question, just let me know.